Hi, everybody. Silence! Okay. Um, First things first, I say 1,000 times a day. Good notes. Good morning. Yes. Um, I think you understand this, but always, dealing with trig and all this stuff. The nature of trig is this. This is general, and it could be any trig function. But you sine an angle, and the answer that you get represents a ratio of sides. On the other hand, when you see the inverse function, immediately in the parentheses, that's the ratio of sides, and the answer that results is the angle. We all know this, right? Because the problem with radians is, if you see 0.5 in a trig question, that could mean 0.5 radians, as opposed to 1/2 as a ratio of sides. So when I deal with the regular students, I don't think they quite understand that. They're just like button pushers trying to get answers. They don't understand what kind of answers they're getting. You understand what I'm saying? Ding-a-ling-a-ling. Don't show this message again, but it always comes up anyway. Okay, I'm going to show the unit circle, but you're never going to what? Get to use it. Never. Never going to happen. Okay, some CAT teachers do allow them to use it and then use it as just a copy answer kind of thing. Oh, what's the tangent of 3 pi over 4? Well, let me just look over here at this blue thing and just extract the answer out of the question. That's like kind of copying, I think. But what's good about it, we already did this, right? We went up to the boards and constructed this, correct? Okay, and then who has a problem with radians? Those that have problems with what? Fractions. To not know instantaneously that 7 pi over 6 is in what quadrant? Oh, he said 4. This is where I got crabby. Okay, 3, because it's just bigger than what pi over 6? 6 pi over 6, which is pi. You know, we're 7 pi over 4. Boy, that's close to 8 pi over 4. So that must be in quadrant what? 4. All right, and so on and so forth. So that's really the use of us looking at this. But you know what's strange? I do want to explain some of the things on here. I talked to a calculus teacher, one of the two that you might get next year. You know, what do you do with this thing? And she basically said not much. But I do want to explain it. And basically what she expects you to know is sine of 30 degrees in a millisecond, you say, what's the answer? What's sine of 30 degrees? 1/2. Without having to draw any stinking triangle or, any looking at a unit circle. So that's what's going to be expected of you. So hopefully through chapter 3, 4, 5, 6, 7, 8, who do we appreciate? You become very, very mastered at that. But let's just keep doing the triangle things real quick. 45, 45, 90. What are the sides opposite of 45? Okay, and then what's the side opposite to 90? But this is called a unit circle. So what they mean by that is these triangles are inserted inside of a circle. All right, and they want this radius of the circle to be 1. So what happens is they divide all these sides by what? So this r is equal to 1. Square root of 2. So 1 over root 2. What's 1 over root 2, by the way? Root 2 over 2. And if you go into next year and they ask you what's the sine of 45 degrees and you don't say root 2 over 2 in a millisecond, you're going to get yelled at. They are so mean in that class. So mean. They're not. But they do get frustrated that you don't know that real fast. Side opposite 30. 1. Side opposite 60. Side opposite the 90. 2. But I want this to be what? 1. So this, and this happens. So then what you notice in the unit circle, whichever unit circle that you see, not as colorful as mine, of course. I made this, by the way. This is mine. I did the colors and everything. It took me a long time. They put these coordinates there. See those coordinates next to each angle measure? And this is how you got to make sense out of the coordinates. The coordinates are actually in the form cosine comma sine. It's true. Because here's 30 degrees. So this side right here that I'm scrolling along here, this side is actually root 3 over 2, comma, 1/2. And then this is 1 for a radius value / hypotenuse of the triangle. So all these coordinates represent cosine comma sine. True story. All right, and then how do you find tangents? You know what tangent is? I know it's ticks. But you remember what it is? It's either sine over cosine or cosine over sine. What did we tell you? It actually has been in the notes before. What's tangent? Sine over cosine or cosine over sine? It's actually sine over cosine. So those that are allowed to look at the unit circle and use it, that's how they find tangent. They take the sine value over the cosine value. What's 1/2 over root 3 over 2? What happens to the 2's? They cancel, so it ends up being 1 over root 3, which is what? Root 3 over 3. Okay, now I'm going to tell. I've done this all the way back since I started teaching in a private school that had, they believed in dog, but we won't get into that. Ever since then, I've said this is how you can remember this. This is how. We already said it. What's sine of 30 degrees? So if sine of 30 is 1/2, I'm trying to help you how you think about this without having to draw a triangle. What's cosine of 30 got to be then? So you remember 1/2 and root 3 over 2 go together, right? Either sine is root 3 over 2 or it's 1/2. So let's go over it again. Sine of 30 is what, everybody? If you get that memorized, then what's sine of 60? Not 1/2. It's root 3 over 2. You switch them. So if sine of 30 is 1/2, what's cosine of 30? Root 3 over 2. So what's cosine of 60? 1/2. See how those all are interrelated there? And then for the love of whatever you believe in, 45. What's sine and cosine of 45? Root 2 over 2. Those really take care of everything. And then you don't have to draw a stinking triangle. So all you have to do is know what quadrant you're in, and then all students take calculus takes care of the signs. And that's really a true story for those that have problems memorizing this stuff. Okay, first one's kind of silly to have to put on here. And actually, yeah, I'm going to leave those up there, change those a little bit. But this is why I did 3-3 today instead of 3-2. 3-1 and 3-3 really go together. You're going to be sine, cosine, tangenting, and all the brothers and sisters of angle measures. Some with a calculator, some without. This is without. Where's 3 pi over 2 land? Where's 3 pi over 2 land? What angle measure in degrees? 270. What coordinate do I extract out of that real fast? If you get that coordinate wrong, I can't help you. What's R? 1. Sir kicks or ticks. What's sine? Sine of this angle measures what? -1. Cosine of this angle measures what? And then let's be lazy. Tangent of this angle measures what? I actually had someone write this on their paper. Undies. Because that's what I said last year. Sorry, it's immature. Undefined. All right, now, for those that were struggling on this, and your worksheet had a lot of these, cotan of 73 pi over 6. First of all, does that reduce at all? Does 73 over 6 reduce? No. So what's the reference angle? What is it instantaneously? 30. Okay, so let me stop this and get some down. What do you break this angle measure down to? It is 72 pi over 6 because this is a multiple of what? 12. That's the key. It's got to be a multiple of 12 because 12 pi over 6 is what, everybody? 2 pi. How many revolutions is that, by the way? 6. So you have 6 revolutions, and then you end up at pi over 6. All right. We got to try to maybe do this the fast way. If not, fine. This is still fast. It's 30, 1, root 3, 2, and then what's cotan? What letter over what letter? X over y. So it's root 3. The other way I was going to say it is, what's sine of a 30? 1/2. What's cosine of a 30? Root 3 over 2. And then it's x over y. So it's root 3 over 2 over 1/2. To know that coordinate, if you wanted to use the unit circle. Whatever you need to do, you got to get there fast. These cannot take long anymore. Not in an honors second year of doing this trig, because we did do this last year. I asked you these specific questions. I did. And actually, I used a CAT worksheet last year that I didn't use this year because I didn't want to be redundant that we did that. So we're 75 pi over 4 land. It's funny. What's multiple of 8 close to 75? I admit on accident it's 72 again. So if you didn't have a calculator, it would be a little tough for some of you. Some are getting it fast, the real numerate people. But the first thing you do with your calculator is divide 75 by 8 and then get rid of the decimal. And then that's how many times 8 goes in this, close to 75. And then the leftover is 3 pi over 4. So this goes away. And then what quadrant is that in? Now, you should be able to get this one fast. What's cosine of a 45? What's cosine of a 45? Root 2 over 2. So what's secant? Root 2. That's what we should be able to do. Anytime you land on a 45, those are really easy. But what kind of sign is on it? Negative. There's the answer. That's how you do it fast. Okay, but now it's time to grab the calculators. What are these? Are these angles or ratios, by the way? Are these angles or ratios of sides? What are these? Ooh, see, that's what I mean. These are, we have half and half. It's angles. See, radians look like decimals, like decimal ratio of sides. But it says cosine of 1.85. What do you cosine? An angle. Why is that not a degree measure? Does 1.85 degrees exist, by the way? Yes, but why is it not 1.85 degrees? Because there's no degree mark. All right? Oh, I thought I didn't tape any of that. The first couple are ridiculous. I got rid of all my calculations on this. I'll just go ahead and do them on there. You just cosine and cosine. But again, these are angle measures. You're getting a ratio when you're done. Hey, 84s, how do we do this when we don't have this button? What do we got to do? You got to do 1 over tan of that angle measure. And then press enter. So again, I'm not yelling at the Inspires for having that button. I feel like it's cheating. Or in the new 84s that they made, they should have put cotan buttons in there. I don't know why they didn't. And then same thing with this, 1 over cosine. And I had some real neat questions like, and it actually does end up in your homework that you're supposed to know this. How come this is, let me think about it for a second, positive? Just want to make sure I did that right. How come this answer is positive? Why? And the answer to that question is, where's 1.32 radians? This is a quadrant 1 angle measure. And you better start thinking about that as far as radians are concerned, decimally speaking. You see that finger? I'm pointing at you, sir. Why is this answer negative for those that typed it in? What quadrant is this angle measure in? It's actually 3. Why? Because this is what measure from here to here? What's that measure? Negative 3.14. So you can get those decimals. You can see them. And I'm fine with that. Is everyone okay? Okay. See? Coming down to something. Look at the next questions. Okay, now I know I pulled it right out of the examples, and I have 2 more after this. But what's 0.9685 now? What is it? Is that an angle, or is that a ratio of sides? It's a ratio of sides. Just wanted to make sure we were taping. And then same thing with B. Look at these directions. And I changed them just to make this question a little bit harder. The directions imply 2 things for letter A. First thing, it implies I want the angle measure in what? No. Yeah, okay, quadrant 4. But also I need it to be in what? Radians. By the way, what's 3 pi over 2 as a decimal? Just so we know and make sense out of our answer. 4.71. And then what's 2 pi? So when you get your calculator answer, it may or may not give you that answer. You need to convert it and make sure it is in that in between 4.71 and 6.28. So this one I will type. It's simple. Second quit. So how do I get cosine of S? What do I do to this? I inverse cosine it, right? So inverse cosine this decimal, 0.9685. I want to make sure I don't make a mistake. Press enter. I'm going to snap that sucker out here and work with it. Is that the answer that I'm looking for? Yes or no? No. You know what this is, though? It starts with an R. It is a reference angle. This is 0.25166 in quadrant 1. Where do I need it to be? And then this makes me angry, the students that try to think, wait, what do I do when just be a simple, this is quadrant 4, right? A simple mover on the coordinate plane. What would the math be to name this angle measure? What would the math be to name that angle measure? 6.28 minus that answer, right? Okay, because then I get those questions. Wait, when I'm in quadrant 4, do I take 2 pi minus? Figure it out. Don't be a robot, so to speak. So it's 2 pi minus answer, right? Because it was a negative, or not a negative. So it's 6.0315. And that satisfies, and I should label that as radians. Whereas the next one, letter B, is without anyone? Without anyone? Without anyone? It says exact value, so without anyone? Without a what? Calculator. No, but there are people in here. Calculator. Wow, look at the monsoon now. Oh my goodness. We're going to be washed away. Okay? All right. So what is it? Where is S at? I hate S as an angle variable. It's weird. But where is S located? Or also, what could it have been? Quadrant what? 1 or 3. But what do they want? They want the quadrant 3 answer. Now, this better be done. This should already be done. What's the answer, those that know it? What's the answer? Oh, where do you get a tangent of 1 over 1? Tangent of 1. Tangent of an angle measure equals 1. What kind of angle measure? 45. What's the 45 in quadrant 3? This is where that calc teacher next year is going to be angry. You got to know that instantaneously. Immediately. Okay? So get that figured out. Draw the triangle if you need to right now. But within this year, you better all get there. Okay? Have to. All right, next one. Oh, you know why I did this? Those with an 84. Because you're stuck. You're stuck with something here. I'm doing a lot of these because these are the toughest ones. By the way, what quadrant are we caring about here? What quadrant? I kind of shortchanged the notes, but quadrant 1, so that's fine. Whatever the calculator spits out at us, that's what they're going to give us. They're going to give us the answer. But how do I type this on an 84? What do I have to do? What do I have to do for this? And it's not the same. This is what I taught you to do. First thing is get your equation ready. So whatever I do to one side, say it. So 1 over both sides. I know it's weird, but what's 1 over cotan? Tan. And then this is tan of 1 over 0.2994. Then you inverse tan this. And no, that is not the same as 1 over inverse tan of 0.29 blah. Completely different. And we better figure that out. Remember I did that on that homework quiz? If you had a calculator, what would you have to type? And you don't have an Inspire. So it's got to be in terms of tangents. Anywho. And there's no reason for me to go over this after this because it does give you the answer that you need. This is in quadrant 1, and I missed a button. And I did that online for millions to see. Or 1. I know. Little feature of this thing. Radians. And you should label it because I have students that don't understand that's a radian measure and not a ratio of sides. That's an angle. Got it? Calculator or no calculator? Cosecant of x equals negative 1 point. What is it? Calc or no calc? Calc. This is not a ratio that you represent or understand or know from the unit circle, let's say. Okay, so how do I do that again? 1 over. And then you inverse. What's 1 over cosecant? That's right in my ear. What quadrant do I want this in? This says I want the answer that's in quadrant 3. Okay, what was the other possibility, by the way? Where else is cosecant negative? Where else is cosecant negative, by the way? Not 2. 4. So I could have asked for the quadrant 4 answer as well. So be aware of that. But what's strange about this one, and I will keep covering this is for those that struggle on this stuff, you do not get the answer right off the bat. Because this answer is in what quadrant? Where's this at? Wow. Where's this answer at? Hold on, I'll find it. This is in quadrant 4. But it's certainly a what kind of angle measure? A reference. It's a reference in radians. So since I want the quadrant 3 answer, I want this one. What's the math for that? Pi plus. Okay, and then I could prove it. Pi plus 0.69. So this is the way I'm going to type it. Pi minus, answer. Okay, 3.83. Now watch. I got to make sure I type this right. I'd have to take 1 divided by sine of this answer, right? What should I get when I type this? What should I get? What should I get when I type 1 divided by sine of this angle measure? Which is the cosecant of this angle measure. What should I get? Negative 1 point. Well, look at that. It's nailed right on the dot. So it's proof that 3.8351 is the answer. Was it 3.8351 radians? Okay, so that's how you do this stuff. All right? Calc or no calc? Calc or no calc? This is a no calc. By the way, 2 root 3 over 3 negative is the same as what? Did you hear all that? The internet didn't because I wasn't playing. We just did something great on this. Too bad you weren't here. Remember I was talking about the unit circle? What's the unit circle radius? What's the radius of the unit circle? 1. So this is a silly little unit circle question that they also throw in there, and I'm just going to cover one so you know how to do this particular kind of example. But you know how else you can prove r is equal to 1? You could use in this purple little pink triangle, whatever, the Pythagorean theorem. 5 over 13 squared plus negative 12 over 13 squared. Square root of that is 1. Okay, and remember what I told you? A coordinate on a unit circle, the x value represents what? Cosine. The y value represents sine. And tangent is who over who? Who's tangent? Who over who? Y. Well, it's actually, in this case, it's sine over cosine. So sine is not that. Sine is negative 12 over 13. 5 over 13. And then what's negative 12 over 13 over 5 over 13? Negative 12 over 5. The 13s cancel. And then you can flip all these. I'm done.